let's talk about solving systems with matrices. Now, matrices are the mathematician's ultimate lazy shorthand. What I'm showing here is actually 3 equations. It doesn't look like it, but what we've done is we've taken the coefficients of x, coefficients of y, coefficients of z, there's an implied equals here, and then this is your number. But what we're going to do is we're going to line up our equations very neatly with x in the first column, y in the second column, z in the third. And then this is equation 1, equation 2, and equation 3. The first thing you need to do is be able to read row elements. So if I want to know what is element A23, what that is the second row and the third column. So here is the second row, and here is the third column. So 8 is element 2, 3. Now, there's a number of things you can do with matrices. You can switch the rows. Of course, you know when we were solving systems of equations, it didn't matter whether you had which equation you labeled 1 and which one you labeled 2. You can multiply rows by constants, just like we did our equations. You can add rows or do any combination of these, just like we did with systems of equations. So if I wanted to write this as a matrix, I'm going to merely look at the coefficients, and wherever there's not a coefficient, I'm going to know it's 1. So this matrix, we're going to use brackets. The coefficient of x is 2. The coefficient of y is 1. Implied equals. And then my constant. Coefficient of x is 1. Coefficient of y is -6. Implied equals. So that is transcribing this set of equations to matrix form. What if I have 3 variables? Well, the first thing I need to do is get everything organized where I have x, y, and z. So I need to rewrite this system. So I have 1x minus 3y plus z, lost my pen there, 6. Now, here I have 1x, but I don't have any y's. So I would put plus 0y plus 3z is equal to 12. Now this one I need to solve. So let me add 5x to both sides plus y. I don't have any z's. And I'm going to leave that 1 over there. So all I've done is rewrite these 3 equations in this nice standard form. So now, transposing this, making this into a matrix, I just take the coefficients. There's my matrix. Now let's go the other direction. What if I want to write this matrix as a system of equations? You see this notation is a little bit different, but you're going to see this. This bar is your implied equals. So if this is my x row, and this is my y row, and there's my equals, this would become 5x plus 2y equals 7, and 0x plus y equals 9.